Right, so this is a little valve amp I built a few years back now. It's nothing special. It was just, you can see it's literally an old amplifier chassis from something else I scrapped. Drilled some holes in the case to put the valves in and put some cheapy output transformers in. Anyway, it was only intended to be a low power amp for my workshop, but it turns out it's a real nice sounding valve amp, but it does suffer in the power department. It crippling 1.5 watts now. That's actually enough for most duty. However, I want to delve inside today and have a bit of a tinker around and just see what effect doing a few changes has on the amp. So let's get it cracked open. It's a bit of a I can't quite recall how this one comes open. That's alright. Oh, here we go. So yes, I think I need to move these out of the way first. Come on. There we go. So let me just put the bonnet catch up. Bonnet stays, I guess, would be the correct term. But so the output transformers are just some little OEP, Oxford Electrical products. I got them from RS Components. So they're like universal output transformers for up to 3.5 watts single-ended. When I actually built this, I couldn't get a great deal of data on these. I've since found some better data sheets and stuff than just the basic what was given, which was nothing really. It turns out that these are, I believe, off the top of my head, I seem to recall it was 2,000 windings from 1 to 2, then 1,000 from 2 to 3, and 1,000 from 3 to 4. So focus. So that's half the secondary if you used that, and primary if you used that one, and then 3/4 and full primary. Now I have the grid 2 going to this tapping point. At the time I did it, I had no idea what this tapping point was. Dear me, this hay fever's getting me a bit. So it turns out I'm running it at 75% tapping. If I move it across to here, I'm 50% tapping. Now initially, if you look at the power supply here, the reason it's like this is because I initially actually had this set up for pentode operation. And then it dawned on me, well, why don't I use the tapping on the primaries and run it in some form of distributed, that's a tongue twister when you're trying to say it with a dry mouth, distributed loading. So as a consequence of that, that's why it only has such a low output power. It's running in near triode mode. So I thought, what I'm going to do, I'm going to keep one transformer as it is, put the same load on each output, and then on the other channel I'm going to change between tapping points, go from full triode to 50%, so much more like an actual ultra linear amp, and then actually connect back to here for pentode operation, because it's too high voltage. You wouldn't connect in pentode operation, you wouldn't go to the same voltage you was connecting the output transformer to. You go to a lower voltage point, an intermediate point. So yeah, and see what the difference is in power, and also see what the difference is in grid drive to the output valves from the input stage. So yes, let's fire it up and see what we get. So it's running, it's on the dummy load, both on 8 ohms. You can see both scope traces are matching. You can just see the yellow peeking behind at the top there. So interesting thing about single-ended class A amps is they actually mostly draw less current when they go into clipping. So you can see on the cathode I've got nearly 7 volts. So if I turn this up, just before clipping, if I turn this up so it starts to clip, you see the bottom is now become misshapen. So yeah, so prop that up on something so it doesn't get the glare off the light. So yeah, try and get them both in. So you see, as I actually turn the volume down, so that's its static DC bias. Start turning the volume up, it will draw slightly more current until it gets to the point of clipping, and then current will start to go down. If I drive it into heavy clipping, look at that. Huge bias shift, because you start then relying on inductive flyback from the output transformer and stuff. So it shifts the bias point of the valve. And so yeah, look at that, massive clipping. So it's a good way of sort of finding the clipping point. So yeah, visually to my eyes, I want to say that's about clipping, and yeah, my multimeter sort of agrees with me. So I'm going to crank this up to 6.9 and we're going to call that clipping. Because yeah, after that that goes, I guess I could try and zoom in a bit more. But it's very hard to tell. So yeah, that's flattening off there. That's definitely flattening off. So yeah, it's about there somewhere. So that is it's a valve amp, so it's usual to have a disparity in gain between two stages. So the oscilloscope reckons about 3.36 and 3.44, close enough to call that the same. Output RMS into 8 ohms, and if you do the maths on that, that's going to be about 1.5 watts. But I'm going to write that down. I'm going to see how much grid drive I need. So you've got 3.4 volts and AC. Well, I'll use the oscilloscope for voltage measurements, or we'll use the meter. Maybe use the meter as well. So quantify the measurements of the grid drive and the output. These aren't going to match, I can guarantee you. That's not calibrated. This is old. They're just a sort of roughish. So the output valve grids are these ones here. Oh, went straight off my scale on that one. So 4.74 and crikey, now that's a difference, isn't it? For one that's needing significantly higher grid drive, that is got the purple wire going off of it, which is no purple, and you know, I'm looking at the wrong colour here. I want the grid, it's the white. There's a white wire coming off of it here. That is going to this one. It's actually grey now. It looks white there. Is it grey? And the other one should be like a purpley colour. I can't quite. Oh no, it's pink. Oh right, yeah, there we are. Pink. Yeah, I was looking at the wrong side of the transformer. So this is the pink one, which is the bottom valve. The grey one here is the top valve. So this transformer here, the grey one, is actually wanting 5.4 and 4.7. Oh, come on, get a good connection. 4.74 and 5.4. Look, that's a big difference, isn't it? Oh, which one do I do? I don't want to get unsoldering both of them. I suppose I'll do it. I'll tell you what. Do it with both of them. I'll do one at a time because I want to see the difference it has in relative signal to the same level of signal input. So I'll go through the top one first, and then I'll go through the bottom one and see what difference I get. That makes sense. So straight away, so the one I've changed is the blue trace. Yellow trace is the white wire, which is the coming off here, so that's still in pentode mode. The blue is the pink wire, which is the one I've changed. That's the grey, the purple. It's going to red, red is going to blue, blue is going to blue. So yeah, the blue trace is the one I've changed. Now, get that in shot. So straight away you can see it's clipping earlier. And there's a bigger disparity in gain, which is to be expected. But yes, look. As you can sort of see, somewhere around there, blue starts clipping. Just not a massive amount, but a tad. If we do my same little thing, checking the bias. So that's the one I've changed. Let me, so if we use the same principle, start to see BIOS drop off about there. Yeah, down at 2.8 volts, whereas the other valve is, careful, probe's going straight through the little tagboard hole. Come here. Come on. See a 6.5. So yeah, let me zoom it in a bit. Yeah, look at that, clipping much earlier. Oh yeah. So it's about, if I say that is the start of clipping, see what, I've lost my meter probe, it's on the floor somewhere. So that one there, 6.2, and if I try and go any higher, yeah, look at that. So yeah, my meter says it's actually clipping slightly earlier, but the, well, it's bias shifting earlier. Yeah, on the scope it's about that point is before clipping. About there actually, not got the scope in yet. So yeah, again, back to about 2.8 volts. So, right, let me write that down and see what grid drive I've got. Right, I've just changed that over. So, powering back up. So the, what is it, blue trace is now running at 50% tapping. So first things first, I've not changed any of the controls, and tracing the blue is now at 2.96, where it was only 2.8 before. So with this control in the same place, and I should have done it with Pentode, I'll do it when I put it back, not Pentode with 75%, I'll do it when I put it back, is I should have actually seen what grid drive it was doing with the same signal level, just to, because it's running global negative feedback. That will change. So out of curiosity, so if everything is the same, this lower valve, sorry, this upper valve should still be seeing, yeah, look, 4.6 odd volts, which is our yellow trace, and our lower valve, this input signal before was getting 4.9 volts, and it's now getting, look at that, you can see it's got more gain, it's dropped off to 3.24 volts. Interesting. So the input stage is working less and it's running more global negative feedback. Should technically have less distortion, but not quite that simple, because I've gone from triode mode to nearer to a pentode mode, so the output valve itself will be introducing more distortion. So hard to say. It's one of those, you need some better measuring equipment than I possess. So let me drive it up to clipping then. Ooh, that's nasty. It has some very nasty artifacts at point of clipping. Let me turn off the yellow trace. And yes, at the knee of clipping, I'm intrigued to see how close that is to bias shifting as well. 7.1. It is literally just as the bias shifts. Look, just make sure I'm on the correct valve here. It's the pink one, which is this one. Cathode is 6.97. That's the one. Bit of a voltage drop on the wire here. The cathode on the other valve is 6.2, so yeah, I'm the correct one. So yeah, you can see it clips asymmetrically. That's a bias thing, that is. It would need bias level changing. That's kind of why the bias shifts as well. So if I think about this right, as the output valve is out of, so the input valve is inverting. So it needs to have a positive going signal on its cathode when the grid goes positive for negative feedback to be applied. So the grid on the input valve goes positive, its anode goes negative. The grid on the output valve goes negative, its anode goes positive, and that means the output of the speaker pen has to be out of phase, sorry, in phase, hang on, oh, I've said too many things, you know when you just confuse yourself, that's what I've just done there. Yeah, that's right, it's a two-stage inverting amplifier, so it's back in phase again, so the anode is in phase with the output of the transformer, so as the anode goes negative, the scope probe will be going negative because that's what we're seeing. So what we're looking at there is that's cut off. The valve's getting to a point where it's having trouble cutting off for whatever reason, but with regards to I mean saturation, not cut off, it's trying to go more negative and it can't. It's hitting a point of saturation and it's oscillating wildly as it does it. But with regards to cutting off, because there's a huge inductive spike, it's able to raise the voltage using the inductive flyback from the transformer. And see if I get that to the point where there's no oscillation, I'll call that, because that also tallies up with no bias shift. It literally, as soon as it starts to remotely oscillate, look, that bias shifts. So call that clipping, and that is measure, where are you? 3.92 volts. So let me write that down. Here we come. So I've not touched the controls, and straight away it would look as though now in Pentode mode it isn't actually clipping anymore. It wasn't clipping it now. It's actually, looks like it's dropped off a bit in gain. No, I want the blue trace, which I have 4 volts, so I've got a bit more. See, it was 3.9 odd. Oh, wrong way. Yeah, 4.16, so yes. Actually got a bit more power, and it doesn't look like it's clipping. What happens if I crank? Yeah, that's definitely clipping. It's actually got more stability than it had. It ultra linear. It's 50% tapping. So let me put that back in there and see what. See if I can get this all in the same frame. Interesting the way it's, so you see how that bias thing behaves differently now in Pentode mode. It actually biases harder because it doesn't have that feedback via grid 2. See, I've got to do this one more by eye, so I'm going to say to my eye, oh, that's definitely clipping. Backing out of that's it, the precipice of clipping, which is 4.8 volts. The yellow one's happily clipping away, it doesn't care, it's a valve amp, it loves it. 4.8, we got 7.26. What happens if I try and go a bit more? Yeah, it just starts clipping, and 4.08. I wonder what kind of grid drive I'm getting at that then. So it is again the pink one, which is here. Wow, look at that. It needs so little grid drive, in Pentode mode. Like the one at the 75% tapping needs 6.13 volts. One in Pentode mode needs a mere 1.87 volts. I can go down to the lower scale. That's quite impressive. Oh, come on. I wonder if then what I see on the cathodes in terms of AC on the input valves. So, let me write that down. 1.87. Let me just write that down. It's actually quite interesting. I think I can't quite get it on the. I might have to just drop the signal a bit. Anode, grid, cathode. So let me just drop the signal down a bit so I can get it on a lower scale, get a more accurate measurement. So 1.7 essentially, and 1.77. So you don't see a massive amount of difference at the cathodes of the input valve, but that's because the input valve has gain. Not a massive amount of gain. It only has a gain of it's a 6N1P, so it only has a gain of 30, and that's with a infinite anode load. Rough rule of thumb, about 75%. So sort of 30 over 4 is 7.5. So we can drop down about 25 to gain. So, but you can clearly see from the amount of anode drive, there is significantly more, I mean grid drive, the amount of anode swing, there is significantly more negative feedback. The numbers follow. So in triode mode, it clips at 2.8 volts and needs 4.9 volts on the grid. It's 75% tapping, it clips at 3.4 volts and needs 5.4 volts on the grid. At 50% it clips at 3.92 volts and needs 6.36 on the grid. And then when you go to full pentode mode, you get 4.08 volts, but look at the way that the amount of grid drive drops off. It really cranks up the gain of that device. I could probably optimize. I'm not really getting a lot of additional the correct voltage on the grid either. I'm not getting a lot of drop on this resistor. It's only marginal compared to the anode. If I go to DC, if you look, the 308 volts to the, so if it'll let me read it, yeah, it's going to confuse things a bit because there's AC superimposed on the top of it. So yeah, 303 versus 311. If I turn the signal off, do I actually have a higher? Yeah, 278 on the anode. I'm actually running a higher pentode grid 2 voltage. Oh, come on. Yeah, 305. So I need to change that, but do some maths and see what the power differences are, and then ponder whether it's worth it or not. So that's the difference in output power. Is a true triode, I get a stonking watt. At 75% that goes to 1.4 watts. At 50% that goes up to 2 watts, and there's a pentode that goes to 2.1 watts. I'd quite like to run it in this mode, to be honest, 50% on grid 2. However, I need to tweak some components to get rid of that instability issue. I don't like that. I need to mess about the capacitance values for extra half a watt. I'm going to leave it as it was. I'm going to put it back to how it was. I'm going to happily run it. It's very stable in that 75% mode. It's only half a watt less power, but it's running nearer to triode, so it's got a lower output impedance, and it's going to have less distortion probably. So yeah, I'm going to run it in that 75% mode. But yes, that was the 6N1P EV to 6P15P EV single-ended output valve amplifier using the RS Components little universal transformers. Should we do a frequency sweep, see how she performs? I've put it down to a nice 2 volt RMS scale, so let's drop down in frequency. Ooh, doesn't like that, does it? What's its lowest frequency? It's happy with it at that level. 59 hertz by the looks of it. You get below that and we start seeing some, ooh, look at that. That is transformer saturation. So you're seeing harmonics manifesting themselves as sum and difference frequencies. So you see it as that, but there's, if you did a Fourier transform, you'd see loads of various order harmonics from that. So about 50 hertz So 2.12 and 2.2 volts. So let's start cranking the frequency. It's pretty flat, really. I've got to give it that. It's I can actually hear the output transformers singing in that. So what's that at? About kilohertz it says on my thing. So yes, it says the same on the scope. Okay, I can actually hear the output transformers. They are singing. Still pretty flat. It's not bad. Not bad at all, really. So yeah, that's right up to 24 kilohertz. It's just fine with it. So yeah, it just has an issue with sub 50 hertz. It's going to start, yeah, you sort of see starts distorting about the 60 hertz mark. You see it's losing that symmetry, and then yeah, ooh. Yeah, that's good for it, no doubt. It's loving that. So anyway, so yes, that was the effect changing the tapping points on your output transformer has. I wish I had better gear to show you what effect it had on distortion. It's say a set power level and point of clipping, and likewise I also remember at the start of this video I said I was going to do it on both channels and I didn't bother. I've just done it on the one because sod it. I'm just having to play about. So yeah, anyway, that is that. Put it back together and put it back on the shelf. And then when the weather breaks, when the weather breaks, spring's not quite arrived yet, has it? It is being an arse in this country. We had a few nice days last week, and then it seems like winter came back again today. So, so yeah. Anyway, the little TAA 300 amp I built has now got main duty until the weather turns cold enough where I can justify leaving a valve amp running non-stop. I'm interested if I turn that down. Yeah, see, it's happy doing the lower frequencies here. So that's 42 hertz. Isn't that like the low E on a guitar or something? 42 hertz. It's only when you start turning the volume up you start getting that distortion. Ooh, yeah. So is that still at higher frequencies anyway? No, it goes away at high frequencies. If that's quite grossly distorted, but if I turn the volume down, so yeah, you just see it's the transformers don't have enough inductance to deal with those low frequencies at that power. Happier to volt though. I should say that would look even worse in pentode mode. The low output impedance of the near triode mode is going to help swamp some of that, but it's not going to be nice for the valve doing that. I shouldn't do that really. So yeah, anyway, yes, that was that. And if you've watched this, then thanks for watching. It's just a random video. I don't know, maybe you've got it on in the background and you just like listening to someone waffle away as you're doing something. I know I do that with various YouTubers like Shango and Radio TV Phone and stuff. Just put it on in the background whilst I'm doing something else. You can just sort of hear them waffling away and you kind of know what they're talking about without even looking at the screen. So anyway, yeah, I've got loads of projects planned. Like I keep saying in my videos, I've got some stuff to do around here. But once I've got a proper bench in, I'm going to have some proper test equipment, no longer dealing with little audio oscillators and stuff precariously perched. I'm going to have it actually set up so everything just works. It's going to take time to get there. It's not going to happen in a couple of months, but when I'm there, it's going to be awesome. So yeah, anyway, as always, thanks for watching and stay crunchy.